Alright, so we have this question here that says prove by induction that 2 plus 5 plus 8 plus open brackets 3n minus 1 is equal to n open brackets 3n plus 1 divided by 2 there. So now we need to show that this statement is true using mathematical induction here. So now the first thing that we do here, which is step number 1, is we need to show that the statement is true for n equals to 1. So what do we mean here? We're going to get this expression that we have here, which is 3n minus 1 equal to, we equate what we have on the right hand side here, which is n open brackets 3n plus 1 divided by 2 like this here. So now, where there's n here, we're going to substitute with a 1 there. So we're going to have 3 multiplied by 1 minus 1 is equal to 1 open brackets 3 multiplied by 1 plus 1 divided by 2 here. Then 3 by 1, we're going to get a 3 minus 1 is equal to 1 by anything, we just get 1 there. So 3 by 1 we get 3 plus 1 we get 4. So we're going to have 4 over to this side. Then this side 3 minus 1 we're going to get a 2 is equal to, then this side 4 divided by 2 we get a 2 there. So therefore this is true for n equals to 1. Okay, so now if that is true for n equals to 1, we go to step number 2, which we call the inductive hypothesis here. So step number 2. So we call step number 2 the inductive hypothesis. Now, under the inductive hypothesis here, we make an assumption, or we assume that the statement is true for n equals to k. So when we make this assumption here, we're going to say where there's n in this expression here, we substitute with a k there. So that's the only thing that we get to do under the inductive hypothesis there. So you're going to have 2 plus 5 plus 8 plus open brackets 3k minus 1 equal to k open brackets 3k plus 1 divided by 2 here. Then now, where there's n there, we've substituted with k there. So now, after doing this, we also need to show that if we add the new term k plus 1, the statement is still going to be true here. So which is step number 3. So step number 3, we have to show that the statement is true for n equals to k plus 1. So what this k plus 1 means here is that on this k term that we have here, the next term now is going to be plus open brackets 3, where there's n we substitute with k plus 1, and on the right hand side, where there's n we substitute with k plus 1 here. So mean that what we mean here is we have 2 plus 8 plus, then here 3k plus 3k minus 1 plus, now since we're saying if this is the k term that we have here, then the k plus 1 term here is going to be 3 open brackets, where there's n we substitute with k plus 1 minus 1 equal to, this side we're going to have k plus 1 3k plus 1 plus 1 divided by 2, like that. Now our goal here is to show that the left hand side is equal to the right hand side here. Now before I start doing that here, you notice to say that starting from the first term here up to the k term, it gives us the left hand side of the inductive hypothesis there. So mean that here, starting from the first term up to the k term that we have here, it gives us the left hand side of the inductive hypothesis here. Meaning that where there are these two terms here, we substitute with the right hand side of the inductive hypothesis there. So where there are these terms, we're going to sub with the inductive hypothesis. So we have k 3k plus 1 divided by 2 plus, here now we're going to have 3k plus 3 minus 1 here equal to k plus 1, we have 3k plus 3 plus 1 divided by 2 So now, here we need to show that the left hand side is equal to the right hand side this side here. So we just start simplifying both sides. If we factorize, we factorize. If we expand the brackets, we just expand the brackets there. So here we have k, 3k plus 1 divided by 2 plus 3k, then 3 minus 1, we're going to get a 2 there. So plus 2 is equal to k plus 1. Then this side we're going to have 3k plus 4 divided by 2 like this here. Right. So I move this bit further. So now on the left hand side here we have two fractions. So this is the same as it's being divided by 1 here. So meaning that here we find the common denominator. So our common denominator is going to be 2. So here we're going to have 2. So 2 into 2 we get 1. 1 multiplied by this, we're simply just going to get 3 k plus 1 plus 1 into 2 we get 2. 2 multiplied by this, we're going to get 6k plus 4 like this here, equal to this side. So let's expand the brackets that we have this side here. So k times 3k, we get 3k squared, k times 4 plus 4k plus 1 times 3k, we get 3k, 1 times 4, we get plus 4 like this here. Then everything here is being divided by 2. So scroll down a bit. Alright, let's also expand the brackets that we have this side. So k times 3k, we get 3k squared. So k times 1, we get plus k plus 6k plus 4 divided by 2 here. We equate it what we have this side. So we have 3k squared plus 4k plus 3k, we get 7k plus 4 divided by 2 like this here. Let's also try to simplify what we have on the left hand side. So we have 3k squared plus 7k plus 4 divided by 2 is equal to 3k squared plus 7k plus 4 divided by 2 like this here. So there we have it. We have that the left hand side is equal to the right hand side here. So now, if the left hand side is equal to the right hand side, then the statement that we have is true for n equals to k plus 1. So now, if this is true for n equals to k plus 1, then we just say the statement that we have holds under mathematical induction there. So let's say the statement holds under mathematical induction there. Alright, thank you.